Hello, and welcome to today's Pedestrian Bicycle Information Center Livable Communities webinar. Today's webinar is titled Tools for Pedestrian and Bicycle Safety and Exposure Analysis, and we will be speaking with David Ragland, Founding Director of UC Berkeley's Safe Transportation Research and Education Center, John Bigham, GIS Program Manager, also with SafeTrack, and Robert Schneider, a researcher with SafeTrack. My name is James Gallagher, and I am the PBIC Communications Manager. I'll be facilitating today's webinar. I'd first like to say hello to today's speakers to make sure they are ready and everyone can hear them. David, John, and Robert, are you there?
We're here.
Yep, hello.
Hi.
Great. Attendees, if you can hear me and if you can hear our speakers, click the hand in the box in the upper right-hand corner of your screen to raise your hand so we can be sure our audience can hear us. Great, looks like everyone can hear us. Before we get started with today's webinar, I want to go over a few administrative details and the functionality of the webinar software. If for some reason your computer or web browser freezes during the webinar, please reload the website and log back into the program. You'll be able to rejoin the session. Please note that attendees will not be able to speak during the session, the webinar. We do expect a large number of attendees on this call, so by muting your audio, it helps us to cut down on confusion and background noise. As an attendee, you have a control box in the upper right corner of your screen that collapses and expands by clicking the double arrows. Though you won't be able to speak, you will have the ability to ask questions by entering them in the question box. If you have a problem during the webinar, you may enter it here. I'll monitor these questions and respond to you if I'm able. Questions pertaining to the presentation may be asked any time in the question box, but will not be addressed until the end of the program when we have built in about 20 minutes for a discussion period. Please feel free to ask those questions as we go along, and we'll get to them after the presentation. Also, when you exit the webinar, there's a very brief survey that will pop up. We would very much appreciate your feedback on our performance. Following today's webinar, you will receive a follow-up email. This email will be sent 1 to 2 days after the presentation and will include a link to download a printable certificate of attendance for 1.5 hours of instruction. If there are multiple attendees at your site, please forward this link to the other participants so they can download and print the certificate with their name. This webinar has been submitted to AICP and may be approved for 1.5 CM credits. The Road Safety Academy, the training and education arm of the UNC Highway Safety Research Center, is a registered provider of CM credits. For more information on the Road Safety Academy, please visit www.rsa.unc.edu. And for more information on future webinars or to visit the archives from this webinar series and others, please visit www.walkinginfo.org/webinars. In addition to these webinars, PBIC offers 4 different in-person training courses to provide technical assistance to professionals and community members in developing pedestrian safety action plans and improving conditions for walking. These courses can be found at www.walkinginfo.org/training. Before I turn the screen over to David, I want to take a quick poll from the audience. If you guys could quickly answer those questions, I'd appreciate it. We'll give about 10 more seconds. And I've got one other poll question. Go ahead, 10 more seconds on this poll. Great, thank you very much. At this time, I'd like to welcome David, John, and Robert for their presentations today. We'll take questions at the end, and David, I'm going to pass the screen over to you.
Okay, thank you. I'm going to give a fairly brief introduction to this presentation. Oops. Here we go. Can everyone see that?
Yes, we can.
Okay, good. I'm briefly going to cover these 4 topics: a brief overview of SafeTrack, some examples of pedestrian bicyclist safety that we've done at SafeTrack, some examples of data reports and data tools, and finally a very brief summary of what we think are some of the main data steps necessary for enhancing pedestrian and bicyclist safety. SafeTrack was founded in the year 2000 with a grant from the California Office of Traffic Safety to reduce traffic fatalities and injuries through education, technical assistance, outreach, and so forth. We have quite a number of institutional partners that you see: public health, transportation engineering, city and regional planning, and others. And we've received funding from a fairly wide variety of sources. We've been doing pedestrian and bicyclist safety since the beginning, and this is emerging as one of our focal areas. A couple of examples. First of all, we've conducted several studies related to safe routes to school in California and nationally. We started this by conducting a report to the California State Legislature on the California State Safe Routes to School program. We've another activity is constructing a database of about 8,000 California schools, primary, secondary, and high school, and conducting mapping of collision of injuries around these schools. This is an example. We would like to expand this into a database where we can be able to rank schools with respect to walkability or potential for walking and biking, and also potential for injury reduction. Another project, this is close to home, obviously, that we're conducting a study of pedestrian and bicycle safety around the UC Berkeley campus, calling the UC Campus Periphery Project. And you can see a map there of several years of injuries. And we're at the end of a phase of that project where we've produced a report that will go to the university and also to the city of Berkeley. We've conducted a number of other studies. This happens to be barriers to transit among seniors. By the way, our reports to all of these are on our website, and also a number are also published. Some examples of data activities. As everyone knows, there is a trend in funding and in resource allocation toward justification by data, by information and appropriate data. One of our contracts or early roles has been a contract with the California State, with California for data support for the Strategic Highway Safety Plan. We provide a number of various reports for this whole program. We also do the 5% report for the non-state highway roads in California. We produce all the data, for example, for these various reports. And the 5% report for California and for every state is on the FHWA website. One tool that we're not talking about today, but we could at some other webinar, is something called Continuous Risk Profile that's developed by a postdoc named Kuwang Chung, who's now working with Caltrans. And it's a method for fitting collision risk to the actual underlying risk. And it has the advantage that it filters out noise to a greater extent than moving window or peak searching, and producing a more stable pattern. You could see just an example of that here. You end up with fairly stable patterns if you look over years, and you're able to identify changes, for example, in underlying risk. We have a number of publications out there that you could access. Finally, just a summary of some of what we consider some of the main data steps for pedestrian and bicyclist safety, and some indications about where some of what we're going to be discussing today. These are roughly in kind of a sequence. The first area would be to enhance crash and injury data, and we've done have a number of projects. One is working to enhance the police collision report in California. That's been actually a major long-term project, very difficult, lots of inertia, but we hope to be able to bring better pedestrian bike safety data or infrastructure and crash data into the police collision reports. And one other project, of course, that's going to be discussed today is our geocoding of California crashes. Data access, we think that a primary step is in improving safety is to make data more accessible to the public and to stakeholders in general. And John is also going to talk about that. Our TIMS website is now publicly available. It took several years working with lawyers from various state agencies to accomplish that, but there it is. Pedestrian bicycle volume. One of the shortcomings in this area of active transportation is the lack of exposure data. And Bob Schneider has been working on that for the last several years here as a doctoral student and now as a postdoc, and is going to be presenting on that. Hazard analysis, we're not talking about today, but we have briefly mentioned our continuous risk profile. We're working on Bayesian type analyses for some of the data we've collected. Causal analysis, countermeasure assessment. Once we're able to compile appropriate data, we want to be able to generate collision modification factors for various road features or countermeasures. 6, benefit cost calculations. We want to be able to allocate resources to get, as Ezra Howard says, the biggest bang for the buck or the greatest potential for injury reduction. And we've developed a safety index, and John is going to be talking about that. Finally, integration with larger roadway data systems. Very often data for active transportation is stored in separate databases or temporary databases. We have now a funded contract to do a pilot to integrate this data with the California data system, which is called TESS, as some of you might know. And we're looking forward to that because we'll be able to conduct analyses where we have pedestrian and we have a wide variety of set of infrastructure data, pedestrian, bicycle volume, vehicle volume, and of course crashes for all the modes, to be able to look at these issues within a comprehensive data set. Just as a final wrap-up here, since I'm going to turn this over to John in a moment, our safety index, which John is going to describe in detail, last year won a FHWA Roadway Safety Foundation Award. And we're quite proud of that. And we've actually developed the tool beyond what it was when we won the safety award. So I'm going to turn this over to John now. And okay.
Hi, everyone. Thanks, David, for the good introduction and to some of the tools I'll be showing here today. For my portion of the presentation, I'm going to show you live demos of our TIMS website and talk about how you can access and visualize pedestrian bicycle collision data, and then look at this safety index or a benefit cost calculator for implementing safety countermeasures. And so TIMS is the Transportation Injury Mapping System, and as David mentioned, many years in development, but the idea is to provide these data and mapping analysis tools to the public. And this site's open. That link there, you can apply for an account application. You'll be sent a password automatically. And one of the things that made this site happen is essentially taking publicly available collision data in California, which is known as SWITRs, so the Statewide Integrated Traffic Record System. So I'll say SWITRs throughout the presentation, so keep in mind that it's just the California collision data. And with the Switters data, what we did over the years is develop a method to geocode or provide a latitude and longitude coordinate on approximately 90-something% of the collisions. And once you have that coordinate, that's what enables you to do different types of analyses and to incorporate into a mapping website. So just an overview of a couple of the main mapping tools on the site. We have this query and map tool, and you can put in specific data queries, get summary statistics, and then download specific collision files with the records of your query. And then it also has party and victim files. So every crash in California, you have one or more parties, and then for every party, you have one or more victims that were injured. So it's a huge database of collision data. And then we have a nice little Google Maps collision display on the final page. And then another tool that we have is this Switters GIS map, and this gives you a more map-centric approach, show fewer collisions, but you can zoom in and hone in on a specific area of interest and only get those collisions in a small space. And I'll show you utilizing that tool to download some data. So I'm going to go here to the Tim's website I have up here. This is the home page, and after the presentation, or during, I guess, you can apply for an account and you'll be sent a password. I guess probably best to wait till after so it doesn't apply and crash while I'm demoing. But so as I mentioned, we have several mapping tools on here and this benefit cost calculator. And so first, I just want to go brief run through of each of these tools. It may be kind of quick for the presentation, but we have tutorial videos, step-by-step tutorials that show you how to do everything I'm talking about here. So you can spend an hour later watching those tutorials on your own time if you like. And so the first tool I want to talk about is this query and map tool. And so basically it allows you to input a time frame. So I can select several years here. And then you can select one of these counties in California, and each county you select, it populates with the cities in the county. So you can focus on a specific county, city, or actually you could choose a particular state highway if you were interested in a single corridor. And so for the demonstration, let's just choose Oakland, California, which is near us here in Berkeley. And once I've chosen a location and time frame, we give you an option to choose from many different types of factors that are available in the collision data. And so the different fields, the day of the week, the time the crash occurred, the number of people injured, all these different factors. And of course, for pedestrian bicycle safety, there's several fields that are appropriate in whether a pedestrian or a bicycle was involved. And then we have a pedestrian action, so you could look at particular types of collisions involving pedestrians. And then you also had different information about the age, the type, party age. So if you want to hone in on youth or older adults, for example, you could do that. And then you could look at only the persons injured in the collision. So all this data is in the Switters collision database, and what we've done is just take out the main fields that people are interested in and build a site to query the data as opposed to having to start from scratch with this a huge data file. And so I'm just going to go ahead and select here. Let's look at bicycle collisions in Oakland during this time period. Now this final page is going to give me a quick summary of several different fields, and then it's going to build a map with the collisions located on the map. And you see for those several years I chose, 694 results. It summarizes the primary collision factor, and then it gives you some other summary fields here. And now what's great is now you can just download this collision file itself. If I click download here, it's going to generate a file with those 694 crashes. And you can see this is what the collision file looks like, the data fields. So it's a wealth of information for all the collisions that occur, It shows you the primary and secondary road, and then it gives you all the other data fields you see here. So we also provide on the site some resources to understand what all these different fields mean. So that's a great tool in itself, just having that information and being able to understand what's out there with the collision data. And so as I mentioned, you could also download party or victim specific information. So it really simplifies what used to be a complex process for getting collision data. And now, of course, one of the most powerful components is to be able to show a map. And so you see here we have collisions that are clustered. And as you zoom in, it'll provide more information about the collisions there. You select one of the clusters, and it shows you, okay, we can zoom into only those collisions. And once you click on a collision, you have information about several of the specific details of where it occurred and what was involved. And then also what's great is you can go to a one-page Street View profile. And this essentially just generates a one-page thing that you can print out. And then you, of course, have the Google Street View here where you can interact and look at that location directly from your computer. So with a few clicks, now you can investigate and look at some of the collisions from this huge database. And so you could also export this to Google Earth, for example, send this data file to one of your colleagues, and that's a simple procedure as well. So a really great quick tool. Within a few minutes there, I've shown you bicycle collisions in Oakland, and now there may be a situation where you'd want to kind of hone in and download only the specific data for a corridor you're interested in. And I wanted to show you the other mapping tool we have. And so we called this the Switter's GIS map, and basically gives you more functionality. You can overlay different types of layers, such as schools or census tracts. You can switch backgrounds to look at just imagery. So it gives you some nice options for exploring the collision data. So here I'm showing Alameda County again, and as David mentioned, we've done some work looking at safety around the UC Berkeley campus, which we're located just nearby. And so I'm going to go ahead and zoom to Berkeley and choose several years here. So let's say 2006 to 2010. And then I can choose, let's look at pedestrian collisions for this demo. And when I show these collisions, you can see them appear on the map. So we had 457 pedestrian collisions that were mapped during those 5 years. So if I zoom in, we have all the same features that I showed on the other map. You can identify the results. You can go to the Street View profile, but you can also look at different types of information, the census tract that occurred in, or different types of other layers here. And I can turn these on the map to show institutions. For example, let me zoom out. You can see the blue are the schools, and we can just show the outline of census tracts. So a great way to hone in on a particular area depending on your research or your field of interest. So I'm going to turn these off and give a demonstration of essentially selecting this data. That's one of the most powerful components, is you're not interested in the entire city, the entire county. You want to be able to select only a small portion of the data. And so we give you some options to select collisions. And so, for example, I could just come here with the drawing tool and say, these are the collisions I'm interested in, and say select these collisions. And you can see now the collisions have been highlighted. Over here, it shows that 19 collisions were selected. I can get some statistics of which collisions those were, and the same type of information you saw, but in a kind of more focused for only those collisions. So that's a really powerful tool, just to be able to select those collisions there. And we also provide some tools. For example, if you were interested in looking at several census tracts of information, you could click on several census tracts and then select collisions again, and it will grab only those collisions in the census tract. We have that for traffic analysis zones, or zip codes as well. And so one of the other tools is essentially a corridor-based selection tool. And we give you some options here. Let me just put in a certain distance, let's say 300 feet. And we can do anything from clicking on adding one intersection. We could select collisions with that. If you had multiple intersections on a corridor you're interested in looking at, you could do that. And each time it'll draw a selection, and you can select those crashes. So for now, let's say that we're interested in a corridor here along the edge of campus. This is actually one of the main corridors coming into campus, but there's actually heavy traffic and pedestrian activity as well, and so it can be kind of perilous to get across this intersection or along this corridor. So we want to select some of this data so we could view this in the potential benefit cost calculator I'll show next. So if I select these collisions, you see they're highlighted again, and now I can click on the collision data file. And it's going to generate a data file with only those collisions that occurred there. And so you can see I have this information along Oxford Street. And then let's say, well, I'm interested in seeing, well, what can we do about the collisions occurring there? What potential safety countermeasures would be useful? And so that's where it comes in our benefit cost calculator tool. And let me bring up my slides again. And the idea with the benefit cost calculator is that, is a way to evaluate these potential safety countermeasures. And the benefit would be the reduction you have in the comprehensive collision cost if the collisions were avoided, and then the cost would be the construction cost to build such a countermeasure. And this calculator, as David mentioned, was originally created a couple years ago in a different format that we've improved now for the web. And this tool is required for California state agencies that are applying for Highway Safety Improvement Program funds to have a benefit cost of any potential projects they're interested in, including that on their application this year. And for this call, there's, I'm going to focus on some of the pedestrian and bicycle specific countermeasures that are available. And the idea with this tool is that it's required for agencies applying for funding in California, but it's really a great tool for exploratory analysis as well, and to really get an idea if something is an effective use of funds. And I say that in conjunction with also a manual that was developed, this local roadway safety manual with the partnership with Caltrans and FHWA and SafeTrek, especially Ted Devini at Caltrans, if he's on the call. He's put a lot of effort into this manual. And it's focused on California agencies applying for fundings and using this tool, but it's really a great resource for conceptually how to go about identifying safety issues and then looking at and analyzing the data and then selecting countermeasures and finding out what is the benefit cost of those countermeasures. So it's a great guide for anyone just looking at exploring these types of things. And so you could use that in conjunction with our tool. And so I'm going to go back to the benefit cost calculator, and I'll just input some basic information here. And so once you've input your information for the project, you want to go ahead and select the time period of interest. And so I think I selected 2006 to 2010 for the pedestrian collision data. So I have a 5-year time period, and then I'd want to select what countermeasures I'm interested in. And so the countermeasures, this is a list that's been approved for use in the California funds distribution, but it's pretty comprehensive. Excuse me. And it provides the type of countermeasure, signalized, non-signalized, or roadway. And then it gives more information. All right, excuse me, having trouble getting through the last 10 minutes here, I guess. But it gives you information about the crash type, the countermeasure, the crash reduction factor, and the lifetime benefit. So all the numbers that go into, the effectiveness of this type of countermeasure. And it gives you specific types of crashes that it works for, all collisions, or pedestrian and bicycle collisions down here, for example. So if you install pedestrian countdown signal heads, it'd only be valid for pedestrian and bicycle collisions, and it would have the crash reduction factor of 25 and a lifetime benefit or 20 years. So technical details, but the idea is that these have been compiled. You can see some more here, the pedestrian bicycle ones. These are the different types of options that are available. Go to the roadway based here. And there's some other ones, install bike lanes, pedestrian crossing. So a good amount in here, and eventually we might open this up to more general types of countermeasures that are out there instead of ones focused and selected specifically for California. So let's just go back here to the, let's say, install pedestrian countdown signal heads. Yes, I choose that one. And then the next step after you've chosen that is to input your crash data. So you could input the number of collisions you had if you had done work outside of this website and you had a number of crashes. You could enter those here, and it would calculate. So if I enter some here, you see that it's listed the collisions I input. It gives you an annual benefit and a life benefit in relation to this specific countermeasure. But let's clear that, and let's use that crash file that I selected earlier. So I'll go ahead and navigate to this file. And there you see this tool has automatically mapped out those crashes that I selected from the other tool. It gives you the information, the time frame, the countermeasure information, and if I choose the crash summary, I have that information here as well. So it automatically counts up the collisions that occurred. It shows you that pedestrian bicycle 14 collisions occurred along that corridor. And so you could also click on each of these, get information, and if you had your own collisions, let's say, for example, it was not in the report, you knew it occurred, you could add another collision to the map. So you could give the information about the collision, say yes, it was a pedestrian collision, and then it's recorded and added to your analysis. So a nice little feature, and integrating the mapping tools that I showed you earlier. And so let's say you've saved that. Now you have the updated numbers here below. And I'll go to the next page where it essentially says, let's input the project cost. So let's say it would cost $300,000 for that. And once you've done that, you'll go to a final summary page. And so you have shown here the summary of the countermeasure and the collision data. And then it gives you down here the benefit cost. The total benefit you get is shown here, total cost, and that's how you get a benefit cost ratio. And so the idea is that this value is what you'd want to include in California, include with your application for funding, but the higher the benefit cost, the more effective, of course, the countermeasure is. So it's a really great way to explore, some of these different types of countermeasures and see, well, you want to put one of these types of countermeasures in, but is it really effective for your area or for that type of data that you're dealing with? So let me go back to my slides. And I included in the slides some screenshots of these different countermeasures. And I guess I went a little quick, so I wanted to show one more thing on the TIMS website, and that is, as David mentioned, we had resources for pedestrian and bicycle collisions around schools. And so one of our resources shown here, we worked with the California Department of Public Health and the Safe Routes to School Technical Resource Center. And shown here are collision maps for every city in California. And so if you click on one of these, what it will do is provide you a summary of some of the school income levels, pedestrian bicycle collisions, and then whether they were previously awarded safe routes to school grants, and then the number of collisions that occur within a half mile. And so these PDFs have been resources for people applying for safe routes to school funding in California. And these are actually interactive PDFs, so you could actually click on the schools in the PDF or the collisions and get information right inside of the PDF. So a really nice feature that I think has been really great for agencies in California to get a quick overview of collisions in their city, near their schools. So with that, I just want to finish up with a mention of our funding that we've been given. TIMS was funded by the California Office of Traffic Safety, and the geocoding grants for the years before that, all the long process that went into developing the database and the site has been funded by OTS, and then the benefit cost calculator was funded with work, Caltrans Division of Local Assistance. So you've seen now exploring collision data, accessing it, downloading it, and one of the keys, of course, as David mentioned, is having the ability to account for exposure. And so Bob is going to talk about pedestrian volume analysis methods here next. So.
Thanks so much, John. As he mentioned, I'll be talking about some pedestrian and bicycle volume modeling and tools that have been developed in its relation to crash risk analysis. So pedestrian and bicycle volume modeling is even broader than its applications for crash risk. I'll be touching on some of those other things as well. Some of the things that we want to, questions we want to answer with pedestrian and bicycle volume models are understanding how many people overall are walking and biking, also where they are walking and biking, and then, of course, relevant to our discussion today, what types of locations may have the greatest risk of pedestrian and bicycle crashes. Thank you. Yeah, I'll do this as a slideshow. All right, we'll start again. There we go. So to really understand the importance of the volume data, I just have an example from Alameda County. We took a look at crash data over 10 years, and this is a typical sort of look at the total numbers of reported crashes at various locations, and we had these shown here. Two of them had exactly 5 crashes reported over that time, the Mission Boulevard site and Broadway in Oakland. If we just had this data, we'd think, well, these have similar crash problems or similar number of crashes. But when we add information about the volumes of people crossing the streets at these intersections, we see a very different story. Since there's many more people crossing at the bottom location, Broadway and 12th in downtown Oakland, the risk of a crash per pedestrian at that location is almost 100 times lower than it is in the more suburban Mission Boulevard location. Mission Boulevard is a 6-lane, relatively high-speed, high-volume roadway, and it has much higher risk per pedestrian crossing. So one thing that we want to understand from looking at data like this is, well, are there certain characteristics of roadways that might have higher risk, and can we make any systematic improvements to those types of locations that would ultimately make it safer for pedestrians to cross? And so having information about the volume helps us answer that question. One example of trying to tackle that particular problem was work we did in Alameda County with intersections along arterial and collector roadways. We had 81 locations where we'd actually taken pedestrian counts and been able to use that to identify the association between pedestrian crash risk and roadway features. Now, what I'm showing here are some factors that were associated with higher numbers of pedestrian crashes. Of course, when you have more pedestrians crossing the street or more motor vehicle volume, you tend to have more collisions occurring. However, with pedestrian crossings, in general, as you have more of them, you see a safety in numbers effect. So the risk per crossing actually goes down. That was identified in the model. But doing this model, we were able to account for pedestrian crossing volumes and then identify features that had certain association with risk. If we hadn't controlled for the pedestrian crossing volumes, we would have identified a lot of high volume type locations and the features associated with those rather than the ones that had higher risk. So we found that right turn only lanes, driveway crossings close to an intersection were associated with higher risk. Having medians at a crossing were associated with lower risk. Not surprising given some of the other research that's been done, but we had some evidence from actual crash data. Now, this volume, or this pedestrian risk assessment that we did is based on only 81 intersections where we were able to actually collect pedestrian volumes. If we had a really robust way of estimating pedestrian volumes at other types of locations, we could get a much bigger data set to give us more confidence in some of these findings and develop better crash reduction factors for pedestrians. But we only have the counts that we used for this. So that brings up the idea of using demand analysis methods to come up with estimates of pedestrian volumes. And that's really what pedestrian volume modeling is about for safety analysis. Now, I'll cover just a couple of these versions of analysis methods quickly and then focus mostly on location-based models because that's what we've been involved with here recently. But just so you know, there's an NCHRP project 0878 that's looking at all these types of methods. And there's also some other research efforts going on in this field. But to give you a sense of what some of these are, first of all, I wanted to just mention the traditional four-step transportation demand model and some of its limitations for pedestrian and bicycle analysis. So these are the traffic analysis zones highlighted in red around downtown Berkeley. What they don't do is capture fine-grained pedestrian movements. We aren't getting pedestrian travel that's occurring within zones, so from one block to another, or if somebody drives from one zone to another but then walks the final 2 blocks to their destination. When they're making that walking part of their trip, they're actually crossing roadways and may be exposed to risk for crashes, but that wouldn't be captured in a traditional model. We also, of course, have simply pedestrian and bicycle counts, and we can go to a number of locations, have interns and students go out and help do counts, but even with lots of help, it's hard to get lots of locations. It took us 2 different years to get 81 locations captured in Alameda County. You can also look at census data, and that can show you some general geographic patterns, but in pedestrian and bicycle use, but it only focuses on commute to work and has some limitations in terms of being the commute mode that people use most often to go to work. So in addition, it doesn't capture the pedestrian or bicycle volumes at an intersection or for a specific street segment. It just gives you general neighborhood level at the census block group. We also have sketch plan methods, which have been used in a number of communities to provide some sense of the relative attractiveness or relative levels of pedestrian or bicycle activity given the features that are available. More pedestrian or bicycle activity is probably going to occur close to attractors like schools and hospitals. And if you put all these together using GIS and overlay them, you can see that some parts of the city may have relatively higher pedestrian or bicycle demand than others. But it doesn't give you specific information about the number of pedestrian or bicycle crossings or number of pedestrians and bicyclists using a particular roadway. We do have a couple of other types of models that have been developed in the last 10 years that do give pedestrian or bicycle volumes and a couple of them are network-based. So Noah Rayford brought over the idea of space syntax and did some work with David Ragland on that here. And it looks at the network connectivity and uses special software to evaluate pedestrian volumes. But it requires that special software and isn't necessarily user-friendly to apply. In addition, Kelly Clifton, when she was at Maryland, developed a pedestrian volume model there that's based on a process similar to the traditional four-step model, but using very detailed pedestrian analysis zones. So each street block space, and calculated the amount of pedestrians traveling from one block face to another and then crossing all the streets in between, taking into account the entire network effect. So that was useful, but also very time intensive. So may not be easy for practitioners to apply. That's led to a number of efforts to develop location-based models, which are a little bit simpler to develop and then use. The approach really is to estimate the pedestrian intersection crossing volume at a particular location, essentially not think about how pedestrians got there or where they're going to, but just say what characteristics of the surrounding area may be associated with seeing higher or lower volumes of pedestrians at this particular location. So it's trying to simplify the process. And here's some examples of researchers who've been doing location-based models in the last 5 or 6 years. And a very quick summary table of these, and I'm not going to describe every single word in here. It's in one of the papers we've done recently for TRB, but I did want to highlight that there's some common factors that are shown in these models to be significantly associated with pedestrian volumes. So population density in the surrounding area, employment density, the number of commercial properties, so retail establishments, and then proximity to some form of transit shows up in a lot of the models as being significantly associated with higher pedestrian volumes. To give you a sense of how we developed our first pedestrian volume model, location-based pedestrian volume model in Alameda County, I just want to go through a little bit of the background of that. We developed a sample of locations to collect volumes at and developed a pilot model in 2008 using 50 intersections, and then did some validation analysis in 2009 using an additional 30 intersections. There are 7,500 intersections along arterial and collector roadways in Alameda County, so we obviously couldn't count at every single one of those. We chose 50 that we thought were representative and did that using a stratified random process accounting for population density, proximity to commercial properties, and the income levels of different neighborhoods to ensure we had a wide variety and would get a good range of pedestrian volumes at each intersection from high to low. And these are the 50 intersections we counted in 2008. From that, the original counts that we took over 2 hours at 2 different times were adjusted for differences in weather and being at slightly different times of day. And we extrapolated those out to a full week count based on automated counters being providing us with pedestrian activity patterns near the intersections. So using 13 different counter locations, we figured out that the composite or the typical Alameda County pedestrian activity pattern looks something like this. The percentage of pedestrian volume each hour of the week, generally higher during the middle of the day and lower at night, a little bit higher on weekdays than on weekends. From our 2-hour count, we could then extrapolate out to the full week using this entire pattern. And from that, for example, we were able to estimate that approximately 5,600 pedestrians crossed the intersection of Martin Luther King Way and 17th Street in Oakland per week. This was in spring 2008. And we did that at all 50 intersections. And so we could compare those with those counts with the characteristics of the surrounding area within a 1/10 of a mile, 1/4 mile, and then a 1/2 mile buffer. And that's what's shown on the map here. Using regression, then, we were able to associate the characteristics of the surrounding area with the actual pedestrian volumes and come up with an equation to represent what those pedestrian volumes were over an entire week. And the factors that I mentioned before were the significant ones in that model. So from the model, we were then able to provide estimates of what the total pedestrian volume over an entire week would be at all 7,500 intersections throughout the county. This focuses in on the Oakland area, and you can see the highest volumes in downtown Oakland. Those are the darkest circles there. Another thing that this simple sort of model structure allows you to do is to use a spreadsheet to forecast future volumes, at least estimate what they might be if certain changes occur in land use in particular. So this is an intersection close to where I live along Telegraph Avenue. I input the data that goes to the model, and then the spreadsheet calculates an estimated pedestrian crossings per week. If there's development in the area over the next few years, we may see that population and employment double within this area. So what would happen if those things occurred? So if I double the population and the employment in those radii around the intersection, you can see that the pedestrian crossings per week go up to 20,000 as an estimate. Also, if this new development draws in more commercial retail properties, what would happen there? We can add that to the calculation and see the impact. So it's a fairly simple tool once you have the model created to put that equation into a spreadsheet and use it. Now, that all sounds great, and it's important to know that this is available and it's possible to do, but we also did some validation testing of the models. And it's important to know what the strengths and limitations are based on how accurate the counts end up being compared to, or how accurate the estimates end up being compared to other counts. So we counted at 30 other unique intersections. Several of them were counted at the same intersection to compare from year to year, but we counted at 30 entirely new intersections to see how well the model would work. And just to show you, if the model predicted exactly perfectly, you'd see that all those blue dots would end up on the dashed line. So if the volume predicted by the model was 5,000, we should have observed 5,000 pedestrians crossing at an intersection in 2009. Well, it didn't work exactly like that, though there was a general correspondence, which is good to see in a model. But generally there was slight underestimation. One other thing to point out here is since we used linear regression in this model, we ended up getting some negative predictions for pedestrian volumes. And that's not going to occur, of course. So in later versions of the model, we used log linear regression, which essentially removes any possibility of giving negative volume results. Just a little bit about the variation in pedestrian volumes. These are 5 intersections that we counted in 2008 and 2009 using exactly the same methodology. And you would expect that there's probably very similar counts using the same methodology, but you see that there's differences. And so some variation does occur. And this is variation that we don't necessarily capture in models. We also looked at the differences between the counts that were taken by our automated sensors. So every single Wednesday at noon, we looked at the volume over an entire year. So all 52 of those counts from Wednesday at noon to Wednesday at 1 o'clock, we could see what the variation was. And so 95% of them are within 20%. But that means there is some variation in these volumes from day to day. So basically that means that models are not going to predict perfectly. And so it's important to keep that in mind. There's certain unexplainable variation in pedestrian volumes due to things like people walking for scenery and store sales one year versus the next that just really can't be predicted feasibly in a planning level model. So that's important to keep in mind. We also did some work on the model to see if we could make it more accurate by including other factors. And to do that, we looked at where it was under-predicting or over-predicting at our validation test sites. From that, we decided we'd try to include proximity to schools and also neighborhood household income in the model as well. So those didn't really end up improving it much. It provided similar alternate versions, but didn't improve it by a significant amount. So we ended up just adjusting the coefficients on the model to make our final recommendation about the model to use. And this is the one that I showed in the spreadsheet a little bit earlier with those coefficients. It's important to remember that these types of models are designed for estimating volumes at the neighborhood, corridor, and community levels. But if you really want to do site analysis for safety or engineering at a particular location, you should probably go out and still do a count because the volumes just aren't predicted accurately enough at any particular location. You can get a broad sense across neighborhoods in different parts of the city, but it doesn't give you an exact count at a location like an intersection. One other application I wanted to show is the pedestrian volume model that we developed in San Francisco, and that's been used for pedestrian safety analysis there. These crashes are over 5 years, and you can see the highest concentration of crashes is in the northeast part of the city, which is the central business district. The model that we developed, I won't go into all the variables that were used, but a lot of them are similar to Alameda County, though not all of them. We ended up not applying the Alameda County here because Alameda County model in San Francisco because there were definitely differences between one community and the other. Steep slopes were a factor in San Francisco, so were traffic signals. So those things were included in the model here. So going back to the map, we can see the concentration of crashes and then compare it to where higher and lower volumes of pedestrians were estimated. And the highest pedestrian volumes are occurring in locations close to where the highest number of pedestrian crashes are, as you might expect. But once we control for these pedestrian volumes, we can then identify locations that have the highest risk per pedestrian crossing. So it really shows a different picture of where high-risk locations actually are. It's not that the locations downtown aren't important for pedestrian safety, but this is a different way of evaluating and thinking about risk. And we noted that the number of these were at unsignalized intersections, multi-lane arterial roadways. Some of them were located near schools, and some were in areas with steep slopes. So this gives us a sense of where we may want to do more systematic type treatment to improve pedestrian safety. And with the last few minutes, I want to just touch on a few bicycle intersection volume models that have been developed. There are fewer bicycle models than there are pedestrian volume models today. San Diego County, ALTA led an effort to develop peak hour bicycle intersection volume there. It includes employment and also Class 1 bicycle paths within a quarter mile, and they've applied it and shown where the highest bicycle volumes would be expected in San Diego. Certainly Ferrer and Piers has done some work in Santa Monica to develop a bicycle volume model there, including some slightly different factors. And then in Alameda County, we did some work to look at factors associated with bicycle volumes at the same set of 80 intersections that we looked at before, and found things like commercial properties being significant, as well as bicycle facilities on the intersection approach and roadway network connectivity. Some factors that may not be seen in other communities would be distance to UC Berkeley. Not, the campus is not located everywhere, so that's specific to this community. And then slope was a significant factor. Both those, slope was negatively associated with bicycle volumes. So a few of these factors have been seen relatively consistently in the bicycle volume models that have been developed so far. And the few ideas for future research would be to look more at some of the intersection design features, the presence of things like traffic signals and median islands. Do those also have an impact on pedestrian volume as well as pedestrian safety? If we can bring them into the pedestrian volume models, we just make the prediction better. In order to do that, of course, we probably need greater data sets to work with, so more pedestrian count locations to develop the models on. These pedestrian and bicycle volume models have been developed so far really apply to typical sorts of locations. They wouldn't apply to tourist destinations or other special attractors. But those types of locations should also, we should be thinking about methods for those. Also accounting for broad changes in economic conditions, such as recessions as well as gas price spikes. Do those actually have an effect on the pedestrian volumes, and how could we integrate that into forecasting for the future? And there's also a need to compare some of the different types of pedestrian and bicycle volume models that have been developed so far. The location-based with some of the network-based models, and compare them and see which ones may predict best and may be most useful for identifying exposure for safety analysis. The volume models have been used for planning purposes and general risk analysis so far. As I mentioned before, really they have the planning level accuracy, not specific for intersections necessarily. And the techniques that have been used so far are really some of the location-based techniques have spreadsheet applications, though other methods are being explored. There's really no universal model that's been developed to date. Different communities seem to have different factors associated with having higher or lower pedestrian volumes, and so it's been important to develop slightly different models for different communities so far, though maybe someday there will be something that's developed that's more universal. So with that, I want to turn it back to James and the folks there to see if we have questions and can lead our discussion.
Thank you. I appreciate this presentation. At this point, we will go ahead and run through some questions. I received several questions during the presentations. A lot of them were directed to John. So I'm going to start with you and the TIM system. First question is, what is the source of the collision data? Is it hospital or police reports?
The data comes from the California Highway Patrol. They aggregate local police reports. Agents, all police departments are required to report the collisions to the California Highway Patrol. And how
did you get these reports? Oh, sorry, go ahead.
Yeah, so the police reports that they compile on the street, they put into the database and send to the Highway Patrol.
And how did you get the latitude and longitudinal data associated with each crash?
So that was an extensive process. I should have put a paper to a link on there, but essentially we developed some custom code to geocode based on whether it occurred on a local road or a state highway. So several different methods. That was a really long process, though. I can put a link in the slides on there to the paper if you're interested.
That'd be great. Is TIMS only in California? And if so, are there other sites for this kind of service in other parts of the country?
I think it's pretty much unique to California. I think there's other systems I know about in some other states, but it's not really open access like this. I think this is really unique in that we took the data that was available and made publicly available in California, but we made it much more accessible through the site, and our site's focused on California. We do have some interest in utilizing the FAR's national collision database and some of the tools as well, but it's focused on California right now, and I'm not aware of any other states that have a publicly available system like this.
Is the collision data reported in real time, or is there a lag between the incident and when it's included in TIMS?
There's quite a lag. We've just included, well, we're about to include the final version of 2010 collision data. So the lag time is 2012 May or June now. So that's about the lag time you're looking at, that 2.5 years till the final data is available. And so that's some concern to people who want the latest data, but I think the trends can be seen from data at that time frame 2.5 years back. And there's some work to improve that in the future, but California's gotten a little bit further behind in compiling their final database over the past few years.
Does the benefit and cost analysis assume that 100% of the historical crashes will be avoided as a result of the selected countermeasure?
I believe so. I'm not as familiar with the specifics of the calculation. David wants to say something.
It depends on the collision modification factor. So whatever that is, it would be the percent reduction. So it wouldn't be there wouldn't be 100%, but it would be based on the collision reduction factor or collision modification factor for that countermeasure.
Another question along that line is, in the TIM systems, there seems to be a cost associated with each injury type for pedestrians and bicycle injuries. Do you know where those estimates came from?
You'll have to look in the resource link I put up there. They were compiled from several different sources that are out there. The Caltrans Division of Local Assistance assigned the final values to those, but they're from several established sources that are available.
When you were calculating the benefit of a countermeasure, is the same CRF applied to all severities?
Yes, I think so. And
do you know how much?
There's a different value of the injury level, of the comprehensive cost associated with that. And in that resource manual, it'll tell you the exact value per injury level.
How much did TIMS cost to develop, and how long did it take?
Well, I don't know the exact cost, but it took me a long time working on it. It's been a long time in the making. Let me think. I think 2003 on the TIMS site, I put a little history. I think the first initial foray into geocoding the crash data was in 2003, and the site we finally made live and publicly available last year. So, a lot of it went into doing the geocoding on the data. That's a key part. I mean, if you don't have the latitude, longitude coordinates, you don't have a site, really. And so, yeah, the cost, it was, I don't know.
You have to remember that in California we have 200,000 crashes a year that are geocoded. And so each year we have to bring that 200,000 value, right? Bring that into the system.
Right, injury crashes.
The injury crashes. So it's quite a task over the years, not only to develop, as John said, the geocoding, the web system itself, but also then to maintain and update the system with increasing data.
Yeah, I think that's the key factor too. Is now that you've created it, you have to keep it going with updates, and it's certainly a large task and requires different background. We have developers and me and other people, so I could go back and look at my timesheets and see how many hours I spent on it, officially on the record, though. But
well, if somebody out there wants us to develop it for their state, we'll give you a bid.
How did you guys get the state to adopt the cost-benefit model as a part of the application process?
That was Caltrans. All of Caltrans work, Division of Local Assistance. Ted Davini, who I think is on this call, is the one behind that. I don't know at what point they started to adopt that. I think it was the first time was with our original benefit cost tool several years ago. But it's become a mainstay in the application process now, and I think there's a lot of good numbers on that link I put you of about the benefit cost and who applied and what countermeasures were funded. So I think Ted and his group are really ahead of the curve in adapting and creating this process.
For the benefit and cost analysis, are there common treatments that we don't have a good crash reduction factors for, like curb bailouts and signalized intersections?
I'm not familiar with the specific countermeasures. The countermeasures included were ones that Caltrans felt comfortable that had enough research behind them. You know, it wasn't based on one study. You know, there's substantial evidence that it did decrease collisions. But it certainly doesn't include all of the countermeasures available through the FHWA. Maybe David has more to comment on that.
Yeah, the source is the FHWA clearinghouse for guidebook for countermeasures for collision reduction factors. And as many of you may know, there would be varying degrees of research on different countermeasures and various degrees of confidence in those collision reduction factors. And of course, one of the major goals, I think, in this whole area of pedestrian bicycle safety would be to improve those collision reduction factors through research. Of course, the database that Bob is talking about, incorporating pedestrian volume and infrastructure in with the larger roadway databases, provides the tool, the major tool or database that's needed to produce those collision reduction factors.
Okay. Within TIMS, can you access the actual individual crash reports?
You cannot access the crash reports. The database that's made available, the SWITRS database, has it restricts the name and identification of the person, and so you can't go back to the actual police reports. You just have the fields that are available in the data set.
Also within TIMS, have you considered counting bike and ped crashes separately to get a more accurate cost benefit on the specific countermeasures designed for pedestrians versus bicycles?
Well, those countermeasures were designed. We're not actually choosing the data sets. I think that's an evolving process. The Caltrans determined that those crash types fit those countermeasures, and it'll be different the next time. And I think over the years that maybe if there's more countermeasures involved, or maybe if there's more data, I think for pedestrian and bicycle collisions, that can be updated over time. Maybe, I don't know if anyone else here has any comments on.
Well, on the FHWA clearinghouse, and those estimates, in many cases there'll be a different collision reduction factor for different crash type, and one could incorporate any amount of that clearinghouse data or guidebook data. For the particular case in California, Caltrans selected out of that what would be appropriate countermeasures. But one could incorporate the entire guidebook or any part of it into such a tool.
Right, and that's what I mentioned earlier. We had interest in expanding kind of to a more general all those countermeasures, so people could explore putting those into the application as well.
All right, thank you very much. I'm now going to move to the questions directed toward to Robert's presentation. Is the pedestrian estimate model being tested in other cities or parts of the U.S., particularly ones that might be smaller or larger than Alameda?
Not yet. The only testing that we've done on it was in San Francisco. I guess that is larger in a way. It's more dense and across the bay, but it was tested there, and based on that initial testing, we decided that we wanted to develop something new for San Francisco. So I think it's worth testing in some other locations to see where it might actually fit well. There may be other counties very similar to Alameda in terms of land use characteristics and the transportation system there that it might actually apply pretty well to, but there's others that it probably won't. So an initial step to take a look at that is to gather the 4 main factors that are needed for the model: population density, employment density, commercial property data, and transit data. Calculate what those values would be for each intersection and then try to apply it. And then go out and take a few counts or compare to previous counts that have been done to see how accurate the volumes actually are. That's certainly something that could be done. We just haven't done much of it yet.
And how did you identify and prioritize the 81 locations when you did your pedestrian counts?
Yeah, so I talked about that pretty fast, but basically the first 50 were selected in 2008, and we did a stratified process to select locations that wouldn't all be high-volume locations or wouldn't all be low-volume locations or be clustered in a certain part of the county. We said that we wanted to have count locations that were stratified along 3 variables. One was population density of the surrounding area within a quarter mile. Another one was the number of commercial properties within a quarter mile. And the third was the income level of the surrounding neighborhood. And using those 3 factors, we created essentially 27 different potential types of locations, each with a high, medium, and low in each of those 3 factors, and selected about 2 out of each of those 3, or each of those 27 groups. So anyway, we had a process to get representation of different types of locations in our first 50 count locations. That's what the initial model was based on. In 2009, we selected 30 more locations based on the help of the Alameda County Transportation Commission, who was a partner in developing this. They wanted to see, have some count sites for future data collection. And so we found those to be a good opportunity to do some validation analysis. And so we used the ones that they'd chosen for that. And some of those were close to schools, and some of them were in various parts of the county that they wanted to have represented in their counting process.
Did the pedestrian safety analysis incorporate injury severity?
The pedestrian safety analysis did not. That is based on just reported crashes of all injury severity levels. And that one was the based on the 81 intersections that I mentioned at the very beginning of the presentation.
Okay. Does the pedestrian crossing estimate model, does that only work at 4-way intersections, or does it also work at T intersections, which likely would see fewer crossings since there are less legs to cross?
Right. We included the entire pedestrian volume at the intersection, which included all legs of the intersection. For this purpose, it was the sidewalk side of a T intersection was also included in the volume. So we were always measuring 4 different legs for those counts, and that's what was used in the volume model.
Now that's a really good question, because for the other analysis that I was mentioning for risk, we took out that fourth leg and only considered the pedestrian crossings that were available. So only 3 had a T intersection for that analysis. So there is some thought that needs to go into whether you use 4 or 3 legs.
In your model, how are commercial properties defined? Are only actual existing structures or businesses included, or are properties zoned for commercial, which may not have anything on there, may just be vacant lots? Are they included?
It was the actual commercial properties according to the tax rolls in Alameda County. We went to the Alameda County Assessor's Office to get the data for the land use code that exists there today. If you used future zoning with current count data, then you wouldn't have corresponding, the correct data corresponding with your count.
Here's another question I just received. With the parties info, is there a way to look at the zip codes of the drivers who collided with pedestrians to see whether the drivers and city pedestrian crashes are more likely in suburban commuters or tourists as opposed to local/urban residents?
No, that data is not available through the Switter's database.
And sorry, I already asked that one. Would the program used to develop the latitude and longitude be directly transferable to other states?
No, not directly transferable. Some of it's custom. I mean, we have custom code that we could utilize for some of the local roads, but the state highway system was really one of the key parts of that, and that was developed. A lot of work went into building that system to essentially we map. You know, it's difficult to map crashes on state highways. You know, for example, if it occurred at an interchange, you can't really map an intersection. So we have something known as a linear referencing system, where it's based on the highway post-mile value of where that crash occurred relative to other known post-mile markers on the state highway. Now, you can build one of those for other states, and DOTs have their own different versions of those, but it takes a little bit of effort to develop that state highway system in order to geocode the crashes that occur there. And I think in a lot of efforts, that's where crashes are difficult to geocode. And as well, on the intersections, we developed the custom code to kind of offset if a crash occurred 100 feet north of the intersection. We incorporated that. A lot of efforts, I think, just snap it to the geocode it to the nearest intersection that was listed.
Are there any factors that might preclude other states from just adopting the TIM system from California?
Are there any factors preventing other states? Is that what you said?
Yeah.
Well, yes. I mean, the framework's there. I mean, we could certainly, if we had another state's crash data, the same type of effort that went in California could be done for other states. But, of course, there's issues, privacy concerns, data sharing issues other states may have. As David mentioned, there were concerns about making this so easily accessible in California. But, you know, the national collision database of fatal collisions has been out there and been geocoded now for several years. So I think some of the concerns are lessening, but each state has their own methods they use to release collision data and how accessible they want to make it to people. I think California, we took advantage that California has a very good public database, and we, in the California Office of Traffic Safety, had the foresight to fund us to geocode that to make it much more accessible to people. Even though that data has been out there many years, a lot of people couldn't really utilize it, I think. Any other? I mean, so I think it's certainly doable, but it's up a lot of different factors involved, and you, instead of just, you know, doing it.
All right. Well, unfortunately, that's all the time we have for discussion. If we did not get to your question today, we will be addressing all the submitted questions and post them to the webinar page on our website. Once again, a recording and transcript of today's program, as well as to view a PDF copy of the slide presentation, this will be available in about a week at walkinginfo.org/webinars. Finally, I want to remind you that a very brief survey will appear once the webinar is ended. Again, we very appreciate you taking a moment to complete it. Thank you again to our speakers, David Ragland, John Bigham, and Robert Schneider. And thank you to all of you for attending today's PBIC Livable Communities webinar.